What's up, everyone? This is LeetCode 200, number of islands. We've done this problem in Python. Now we're going to do it in C++. So you can read the problem statement if you want, but basically we're given a grid where ones represent islands and zeros represent water, and we have to count the number of islands. And so the way this works is that um, if we have two pieces of land, right, the one represents land. If you have two ones that are connected vertically or horizontally, they're part of the same island, right? So for example, this right here is all one island, okay? Because they all connect to each other either horizontally or vertically, okay? So there's only one island in this example. Here, for example, there's actually three islands, right? Because you can see these don't connect horizontally or vertically, right? This one cannot connect to this one horizontally or vertically. And again, diagonally is not an option. Here, they can't connect horizontally or vertically, right? Because they're blocked off by some water. So these are all separate islands. So there's actually three islands, right? In example 2. Okay, so how do we count these islands programmatically? That's kind of the tricky part of this problem. And there's a suboptimal approach that's a little bit more complicated, but I'm going to go through that example first because I think it'll teach you this problem pretty well. And then I'll show you the simpler solution, which is a lot less code. Okay, and so the gist of how we're going to solve this problem is we're going to use a visited set, okay? And the way this works is that we're going to iterate through the matrix or the grid, okay? Right? And when we encounter a 1 that's not in a visited set, we're going to basically start running a BFS function on it, right? So from here, we're going to use these coordinates and we're going to call a BFS function on it. And we're basically going to recursively check all its neighbors. And from that neighbor, check all those neighbors. And from that neighbor and this neighbor, check all those neighbors, or directionally. Okay? And add it to the set, the visited set. Okay? And the way we keep track of this being one island is before we enter the BFS function or right after we exit it, that's when we append 1 or increase the island counter by 1. So when we're actually doing the recursive checking for all these adjacent nodes, or directionally, we're actually not updating this, okay? It's only after we handle basically all the recursive calls that we update this, okay? So yeah, how we're gonna do it. We're gonna use a BFS and using a visited set, okay? So like I said, this suboptimal approach is going to have quite a bit of code, but it will make sense. It's pretty verbose, but I think that's just C++, honestly. I think this problem is a lot less complicated in Python, because in C++ you just have to do a lot of things like passing the grid as a reference to, some other function, the BFS function or whatever. Okay, but you're here for C++, so let's do it in C++. Okay, so let's get the length of the rows. So we're going to do size, the length of the columns. We're going to do 0 dot size. Okay, then we're gonna have a pair for the visited set. The reason we have a pair is because our visited set is gonna have the coordinate points, okay, the row and the column. So that's why we have two ints, okay. Then we have the islands. Initially, it's gonna be 0, and this is what we're returning, by the way. Okay, islands. The number of islands there are in the grid that we're given. Okay, and we're gonna have another vector, which is gonna be a pair of ints also, and this is just going to be the directions so that we can go up, down, left, right, okay? When we have a specific coordinate point. So we're going to say 1, 0, negative 1, 0, 0, 1, 0, negative 1. I mean, I'll space this out a little bit so it's easier to read. Just like that. Okay. Now, here's where we do the, basically iterating through the, where we iterate through the matrix, okay? So what we're going to do is we're just going to have 2 for loops, okay? So we're gonna, that's kind of the point of getting the rows and the columns, the length, right? So I'm gonna say int r is 0, right? Well, r is less than rows, plus plus, let's say for loop, c is for columns, c is less than columns, plus plus this, and then we're gonna say if the grid, right, is equal to 1, meaning it's if it's an island, right, as we're iterating through the grid, and it's not in the visited set, so we're gonna find this, we're gonna say rc, right, visited dot end, we're gonna pass it bfs r the grid visited directions. Okay, we actually have to implement the bfs function, which is what we'll do next. And then here's where we upgrade the islands. Okay, so this is kind of just boilerplate stuff, or setting up the problem. Now we actually have to do the bulk of the work, or the kind of the important logic is the actual bfs function. Okay, so we're gonna say bfs, right, and we're gonna say int r, int c, vector, vector, star. This is our grid, right? And we have, this is why I'm saying it's, the problem is a little bit more wordy in Python, verbose, because you have to pass it a few things. I think you can use like lambda functions or whatever, but I'm personally don't really use those. I just kind of do my problems like this. Okay, so we're gonna say directions. Directions. Okay, so there, right? That's our function. How we're gonna call it? Okay, so we're iterating through this grid. Okay, when we encounter a 1 that's an island and it's not in our visited set, we basically have to run a BFS on that specific coordinate point. Okay, so when we call BFS function on that coordinate point, we're gonna add it to the we're gonna create a queue and basically put it in our queue. Okay, so we're gonna say queue and add it to our visited set, obviously, because we just visited it. So we're gonna say RC, okay, and push this. Say RC, okay. And the point of well, we're using a BFS, right? So that's why we're doing a queue. And I'll explain this a little bit more as we go. Okay. So we're using a BFS, that's why we're using a queue, right? So we basically put this coordinate point into the visited set as well as a queue, and we basically go forward directionally from there, okay? And then we append these to the queue also and go forward directionally from there. And we keep doing that until we basically account for all the nodes for a specific island, okay? So I hope that makes sense. Like I said, I'm sorry if my explanation is not super clear as I go along, but like I said, I'm just making sure I write the correct code because this is more verbose in C++ compared to something like Python. So I need to make sure my syntax is correct. Okay, so we're gonna say auto row column, right? Basically just getting the row column from the queue, because again, the nodes in the queue have the row and the column coordinate, okay? Right? And we're gonna say for auto RDC, right? Directions. And so we're gonna iterate through these directions and basically, so we pop something from the queue, right? Which is the coordinate points for a specific node, because we're going forward directionally. Maybe any of these coordinate points get put in the queue. We are gonna pop it at some point. And when we pop it, we're gonna basically check forward directionally from there. So we're gonna add either a 1, a -1, depending on the row or the column, depending what direction we're going, right? So that's kind of the point what we're doing in this for loop here. Okay, so we're gonna say int r, int new row is gonna be row plus dr. Int new column is gonna be column plus dc. Okay, and here's where we have to do the checking. We're going to say if the new row is greater than 0 and the new row is less than the grid dot size, and new column is greater than 0 and new column is less than the grid, right? Less than the grid of 0 dot size. What we're checking here, by the way, is just making sure it's in bounds. Okay, that's all we're doing. Because when we go forward directly, obviously we maybe go up when we're here. Obviously we would be out of bounds, right? So we're just checking that we're in bounds, and we want to make sure also that when we go a particular direction, that's also land. So we're going to say grid nr nc is equal to 1. Okay, and visited dot find of nr nc is equal to end. Okay, if that's the case, we're going to do q dot push nr nc. Okay, like I said, this is more verbose in Python and C++. So sorry if it's a lot of code, but just a little bit complicated to do this problem in C++, at least the suboptimal approach. Okay, so we do that, and I think here we can return 0. And I think that should be it. And I'll run through the code, obviously. Okay, I don't want to just write random code because you might be lost since there's so much code. We're going to run this. Oops, I typed too fast. Return 0, right? Okay, this I think won't have any problems. Nice. Okay, so let's explain this step by step, and I'll explain the BFS function when we actually call it. Okay, so we're iterating through this, okay, from left to right, because we have a particular row and we're iterating through the column. So we have this first row and we're going column by column. So we're going here, then here, then here, right? And what we're doing, well, first of all, we're setting up the visited set, the island variable, and the directions. Okay, that's kind of simple stuff. And then we're iterating through the actual grid. Okay, and when we encounter a cell that is 1, meaning it's land, and it's not in our visited set, then that means we need to basically run the BFS on that cell. Okay, so these coordinate points. So we're gonna call BFS on this cell here, right? The first cell, because it's a 1 and it's not in visited. So when we call BFS on this, what we're actually doing is we're, first of all, inserting this into the visited set. Then we're pushing this onto the queue. Now, while the queue is not empty, and obviously it's not empty because we just pushed it into the queue, we're going to basically pop this, okay? So we're going to pop these coordinates. We're going to go forward directionally from there, okay? Up, down, left, right. When we go up and left, we're out of bounds, so we're not going to do anything. When we go right and down, the cells are 1, so they're land. And on top of that, they're in bounds. And on top of that, they're not in our visited set. So we need to also put these in the queue and go forward directionally from there and add those to the queue if they're 1s and in bounds, etc. Okay, so that's kind of how we're handling all the cells that belong to the same island. Okay, we're basically putting them in our visited set to mark them as visited. Why do we do that? Is because when we exit the BFS function, right? Let's say we handle all this. Well, when we go here, we know that this is part of the same island that belongs up here. So we don't actually want to upgrade, or sorry, we don't want to increment the islands variable. So that's kind of the point of handling it this way, okay? So when we're down here, for example, this never got touched, right, up here, because you can't go forward directly from anywhere up here and put this in the visited. So this is not in the visited. So when we go here, we know this is a new island, and so we have to run BFS on it, okay? And so that's why we would increase the island count here again. And then down here, right, this is also never touched. It's not ever put in the visited set up here because you can't go forward directly from here and hit this cell. So this is a new island also. So these belong to the same island. So we increment island again after we exit the BFS function. And so that's how we get 3, okay? So I hope this makes sense, okay? don't be confused by all this code, because really this is just a lot of boilerplate Python stuff. Like, the actual logic is very simple to follow, just as I was explaining. But I'll show you a simpler solution, okay? That maybe will make more sense. This is kind of a wordy solution because we're using a bunch of stuff, right? Like a bunch of like we're using this directions, we're using this visited set, which might be even more confusing and also adds more overhead because we're using a data structure. So how we do this, to do this in a simpler approach, what we can do is we can, first of all, let's get the rows, the columns, because we're going to iterate through it also still, okay? But let's delete this visited set. Let's delete this directions here, okay? And now let's keep this all the same, okay? Now already our code is cleaner. How do we make this cleaner though, okay? And what we can do is, first of all, we need to pass it the grid, okay? So, because that's important, because we need to use that. But this visited set can go away. This directions can go away. And we will use the direction still because we have to go forward directionally, but we don't have to actually have like a vector. We can just do it manually, okay? And I'll show you what I mean. Okay, so let's delete all this. Okay, so what do we do here? Well, why don't we check what we passed it and check if it's in bounds? Okay, so we're gonna say if r is greater than or equal to 0 and r is less than grid.size, right? We're just checking if it's in bounds. That's all we're doing. And c is greater than 0 and c is less than the grid of 0 dot size, right? And grid of r c is equal to 1, equals to 1. Why don't we do something if that's the case, right? Now you may be asking yourself, why are we doing this? Because if we're iterating through this grid and we pass it a coordinate point, of course it's going to be in bounds. So why are we doing this here, right? Well, the reason we're doing this is because we can just call this function on itself, right? So that we don't have to write so much code and we don't have to use a visited set or anything. So what we can say is, if we pass it something, okay, and it's a 1, it means it's an island, okay? Well, if it's an island, can't we just mark it as a 0 to kind of make it visited? We could, right? So we could just do something like this. We could say, this current island that we're on, let's set it to 0 because it's visited, okay? And on top of that, we can call BFS on forward directionally from where we're at, right? So we can say r plus 1 c grid, boom. Here I have my semicolons. So let me just copy paste this, make it faster, right? We can do this. Here we can do c plus 1, c minus 1, just like that. And I believe we should be good to go. Compilation error. What did I do wrong here? Oh, sorry. We actually don't need this. This is a visited set. I forgot to delete this. We're not using a visited set anymore. The way we're marking nodes as visited is we're just delete it here as well. Ollie. There you go. So we're not using a visited set anymore. This kind of simplified solution is a little bit more efficient, right? See if LeetCode's really slow. Is also my browser. It should work though. Let me reload. Copy. Same code I had. I'm gonna paste it. There you go. My browser's a little bit slow sometimes. Let's submit. And there you go. Okay. So what are we doing here? Okay, let me explain this different approach that's a little bit more simplified. Okay, we're going through the grid. Okay, and again, we're doing rows on the outer columns, or sorry, rows in the outer for loop, columns in the inner for loop. So we're handling a row, and we're going basically column by column. So we're gonna go here, 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 and then we're gonna go like this. Okay, so basically going like I showed you in the drawing. I don't know if I showed you, but we're basically going like this. This is how we're iterating through our grid, okay? And when we encounter a 1, okay, we're going to call BFS function on that. So we're going to go forward directly from there, and then from those, keep going forward directly until we have no more ones, okay? And you can do it like that to basically not have to use a visited set, right? And so that's kind of the neat part about it. Now the issue obviously is when you call it on the right, like when you're here, you're calling it. What you would check in the first solution also if you have a 0 or not. Like you're still going forward directly, even for places where there isn't a 1, there's a 0. But so it's the same solution, and what I showed you before and what I showed you now. The only problem here, or not problem, but the only difference here is we're not using a visited set. We're just basically, like when we're here and we go to the right, up, down, left, all that stuff, right? When we go right, we have this one here. We're going to turn that to a 0. Why? Because it's part of the same island, right? Like, let me do this really quickly. So when we're here, we call BFS on this. Well, we go forward directionally, right? These are part of the same island. So when we set them to 0, right? When we exit the BFS and we go here, we're not actually going to handle this because it's already set to 0. These are all set to 0, right? So we don't handle these, the BFS. So that's how we keep our island variable still tracking properly, is because we never actually handle this one, or this one. Well, honestly, an example 1 as well. We don't handle this one, this one, this one, this one, this one, outside of the BFS function. I mean, we don't handle it because they get set to 0. Whereas in the first example, we don't handle them because they're in the visited set. Outside the BFS function, because we set them to visited in the BFS function when we're doing stuff recursively. Okay, so just make sure you understand kind of the flow of the program, and this will make sense. Sorry for this video being a little bit long, but like I said, Python is a little bit more verbose. So need to make sure I get my types correct, like my ints and my semicolons and stuff that you don't have to worry about in Python. But anyways, I hope this helped, and I'll see you in the next one. Peace out.